continuing with our quadratics. So what we're looking at now is our goal is I can solve quadratic equations by completing the square or by using the quadratic formula. So far you have been solving quadratic equations. We did it actually in the last unit. But what we're going to do in this unit is we're going to solve them by using different methods. And this today what we're going to look at is completing the square to solve them, as well as using the quadratic formula. Okay, so 3.2. So remember last unit we solved quadratic equations by factoring. Okay, and so remember when we factored, what we wanted to do is we wanted to see if there was any factors here. Now you can see that there's a common factor here of a 3 and of an x. So that's what I would do first. I would take a 3x out of both terms, and we would be left with x plus 8 equals 0. And then our purpose was at that point, now that we had it factored, is we would set each bracket equal to 0 and solve for x. So that's what we wanted to do, and maybe we'll just write that to the side so that we kind of remember that that's what our purpose always was. You want to make the brackets 0. So when I make those brackets equal to 0, I end up with, obviously here, how do I get 3x equal to 0? Well, that means that x would equal 0. And for the other bracket, if I wanted it to equal 0, it would mean that my 8 would have to be a negative 8. Okay, so we solved that. Now that was one method. Now what we're going to look at now is different ways. So the first way is we can solve it by completing the square. Again, we're starting with the same equation we did up here. You can see it's identical. And this time what we're going to do is complete the square. Well, remember to complete the square, first of all, the number in front of the x squared has to be a positive 1. It's not, so that's the first thing I have to do is I have to take out a 3. Not a 3x, a 3. So when I divide this term by 3, I end up with an x squared. And when I divide the 24x by 3, I end up with 8x. And then what we did is we took, and I'm going to change my color, we take half of that number, so we take half of 8 and we square it. Well, obviously half of 8 is 4, and we're going to square 4, which is 16. So we're going to add 16 and subtract 16. So we have 3 bracket x squared plus 8x plus 16 minus 16 equals 0. We know that the first terms create the perfect square. So that means that we would have 3 bracket x plus 4 squared. And what we do is when we take out this negative 16, I also have to multiply it by the 3 that's in the bracket, because with FOIL that's not really a negative 16. It's actually a negative 48 equals 0. Now so far we haven't solved for x here. All we've done is we've completed the square. So this way is a lot, for especially a question like this, it's a lot more complicated, a lot more steps. So now let's see what we do with this. So once the square is completed, you can rearrange to get x by itself. Remember, that's what we were doing up here too. We got x by itself to solve for x. So here's going to be just a little bit harder to get it by itself. So we have, and I'm just going to take our equation that we have here. So we have 3 bracket x plus 4 squared minus 48. So the first step that we're going to do with something that has its square completed, and that's what's going to come in over at the side, is we are going to add or subtract the constant on both sides. So the constant term here is the negative 48. So we want to add and subtract that to both sides. And when we do that, we end up with 3x plus 2, 4, sorry, squared equals 48. Okay, now remember we want to get x by itself. So the next thing we have to do, and some have more steps than others, and actually I can just get rid of this, is we want to divide both sides by the front number. So in other words, in this case, the number 3. So when I divide my left side by 3, I'm just left with the x plus 4 squared. So that's the next step that we would do. So we would have x plus 4 squared equals, and 48 divided by 3 is 16. All right, so we're getting a little bit closer to get x by itself. The next step would be that we need to square root both sides. But the important thing here is when we're squaring both, taking the square root of both sides, that when you square root a positive number, such as the 16 here, there will be both a positive and a negative square root. Okay, so when we take the square root, so what happens here is when I take the square root of this step here, is I end up with my x plus 4 equals, and the square root of 16 is 4, so I need the positive or negative 4. Okay, so we're almost done here. Now the final step here in a sense, well not quite the final, so we need to add and subtract the remaining constant to isolate x. Okay, so the remaining constant here is a positive 4, so I need to subtract 4 from both sides. So I have then with me x equals, we have a positive 4 here minus this 4, and I'm going to put a comma, and we also have a negative 4, and we're subtracting this negative 4. And when we do that, we get 4 minus 4 is 0, and a negative 8. So if you notice, we end up with the exact same answer. Okay, and you're thinking, why would you do it this way? It's so much more complicated. Well, it's more complicated in some respects. Now, mind you, if the square was completed already for us, it would have cut down a little bit on the work. But if you notice, we do get the exact same answer mathematically. Okay, so let's take a look at this. Obviously, you wouldn't do that process for something that will factor, right? I mean, it wouldn't make any sense. If you could factor it, why would you go through all of this work? Okay, but unfortunately, not all expressions can factor. So if we actually completed the square and solved, just like we did with real numbers, what we end up is we end up with a handy formula that works for all quadratic equations when we're solving them. And it's called the quadratic formula. Now the quadratic formula is kind of like a monster, or at least I call it a monster. So it's called the quadratic formula. And when we're looking at the quadratic formula, what happens is we end up with x equals negative b plus or minus, and that's where we get our two roots, the square root of b squared minus 4ac all over 2a. And where we're getting these a, b's, and c's from is from the standard form that has ax squared plus bx plus c equals 0. So that's where our a, b's, and c comes from for this equation. So this is really important, quite important, and we should probably put that on the bulletin board somewhere so that we can take a look at it. So let's take a look now on actually using the quadratic formula to solve a few questions. Okay, so what I'm going to do is I'm just going to stop the video and we'll start fresh with our examples.